All right, let's take a look at our practice test. We're told to solve each word problem. For the first problem, we have that a freight ship left the port of New Orleans 7 hours before a cruise ship. The ships traveled in opposite directions. The cruise ship traveled at 27 miles per hour for 3 hours. After this time, the ships were 381 miles apart. What was the freight ship's speed in miles per hour? All right, so my advice if you're trying to work on a motion word problem and you're struggling, always set up a table. It's very, very useful. So before I do anything, I'm just going to go down here. And again, you can set this up with some scratch paper. I'm just going to put my distance formula. So d, the distance, is equal to r, the rate of speed, multiplied by t, the amount of time traveled. And in this problem, we have a freight ship. So we have a freight ship, and then we have a cruise ship. Okay, so those are our two scenarios. And again, the distance is in miles, the rate is in miles per hour, and the time is in hours. So you got to make sure all that stuff matches up. So let's come back up here and let's think about a few things. So first off, if I want to get a rate of speed for the cruise ship, it's actually given to me in the problem. It says the cruise ship traveled at 27 miles per hour. It also gives me a time of 3 hours. So let's just fill that out. Coming back here, for the cruise ship, everything is given to me. The rate is 27 for 27 miles per hour, and the time is 3 for 3 hours. And if I multiply those two together, I get a distance traveled of 81 miles. So this is already done for me. I need to figure out the freight ship now. And for this one, I don't know what the rate of speed is, right? It says, what was the freight ship's speed in miles per hour? That's what I'm trying to determine. So let's let x be equal to that. So I'm just going to put f period s period for the freight ship, and it's going to be the speed in miles per hour. Okay, let me make this E a little bit better. And I can probably make this P a little bit better, just so things are more legible. Okay, now thinking about what's going on here, again, if X is my speed in miles per hour, let's go back. Let's put this into the table there for the rate. And now I just need to get my time. And for the time, you just need to read back through the problem. It tells you right here that a freight ship left the port of New Orleans 7 hours before a cruise ship. Now, the problem tells us that the cruise ship traveled at 27 miles per hour for 3 hours. So if the freight ship left 7 hours before the cruise ship did, I need to take the time that the cruise ship traveled for, which is 3 hours, and I need to add 7 hours onto that because, again, it left 7 hours before. So 3 plus 7 is going to give me 10. So coming back down here, this, for the time here, is going to be 10. Now again, to get the distance, you just multiply across. So 10 times x is just going to be 10x. Now with these types of word problems, you generally have to do something with the distance in each case to get an equation. So you have two scenarios that usually come up. One is going to be where you have opposite directions, and then you need to find a sum. And then the other is going to be where they're traveling the same distance, so you need to set them equal to each other. In this case, they're going in opposite directions. You see here that it says the ships traveled in opposite directions. So in other words, and this is not going to be to scale, let's say this is the starting point. One goes this way and another one goes this way, for example. And it doesn't have to be that one goes left and one goes right. Again, this is just a simple illustration to show what's going on. So we know at the end of the day, the distance between them, so in other words, from right here to right here, if we measure that whole distance, it's 381 miles because it tells us after this time, the ships were 381 miles apart. What I'm going to do is take the distance from the freight, which is 10x, and I'm going to add that to the distance for the cruise ship, which is 81, and I'm going to set this to 381 for the total distance between them, 381 miles. That's all it is. Let's come down here and let's solve this. So let's subtract 81 away from each side of the equation. This is going to cancel. You'll have 10x is equal to 381 minus 81 is going to be 300. Let's divide both sides of the equation by 10. And we're going to find that x is equal to 30. So when we think about what x means, again, this was the freight ship's speed in miles per hour. So it's going to be 30 miles per hour. So the freight ship was traveling at 30 miles per hour. So to check this, we know the cruise ship traveled at 27 miles per hour for 3 hours. So it basically traveled 81 miles. Then we also know that the freight ship traveled at 30 miles per hour for 10 hours. So that's 300 miles. So again, if somebody starts here and goes 300 miles, let's say this is 300 miles like this, and then the other person, let's say they start here and they go, let's say 81 miles like this. Well, at the end of the day, the distance from here to here is going to be the sum of the two, right? The 300 miles plus the 81 miles. So the total distance would be 381 miles as given to us in this problem right here, right? The 381 miles apart. So this is the correct solution. The freight ship speed in miles per hour would be 30 miles per hour. All right, let's look at problem number 2. So now we have that a cargo train left Los Angeles and traveled toward Las Vegas at an average speed of 12 miles per hour. A passenger train left 3 hours later and traveled in the same direction, but with an average speed of 30 miles per hour. Find the number of hours the cargo train traveled before the passenger train caught up. All right, so once again, I'm going to set up a little table. So I'm going to put distance is equal to the rate of speed times the time traveled. And in this case, we're going to have a cargo train. So let me just put CAR for that. And a passenger train, I'm just going to put PAS for that. Now coming back up here, what we want to find is the number of hours the cargo train traveled before the passenger train caught up. Now that's a lot to write. So let me just put let X be equal to the number of hours, and I'll just put for the cargo train. And I think that's good enough. Again, if you want to make something longer for your notes, that's really up to you. All right, so let's start filling in the table. It tells us specifically here that a cargo train left Los Angeles and traveled toward Las Vegas at an average speed of 12 miles per hour. So I know that the speed or the rate is 12 miles per hour. And again, I'm letting X be equal to the number of hours. So I'm going to put in a 12 here and an X here, and the distance would be 12x. I just multiply. Let me make this better. So for the passenger train, coming back here, we read that a passenger train left 3 hours later. So stop for a minute and think about that. A lot of people make the mistake and go x plus 3 on that. You don't want that. You want x minus 3 because it left 3 hours later. So that means that this passenger train is going to travel for 3 fewer hours than the cargo train. So you want to take the number of hours that the cargo train travels for. You want to subtract away 3. So you're going to want x minus 3 there in this position for time. So x minus 3. And then for the speed, it's actually given to us here where it says 30 miles per hour. So let's put 30 in here. And so if we multiply across, you're going to get 30 times the quantity x minus 3. Let me make the 3 better. Okay, so to get an equation here, we're not going to find a sum. In this particular case, remember, they start from the same place and they arrive at the same place. It says find the number of hours the cargo train traveled before the passenger train caught up. You can imagine leaving your house and going to a park or something, and maybe your friend leaves a little bit after you and they catch up to you on the way. That's what we're saying. So you travel the same distance. And so what we want to do for this type of problem, we want to set the distances equal to each other. So in other words, the distance that the cargo train travels, which is 12x, is exactly equal to the distance the passenger train travels, which is 30 times the quantity x minus 3. So we just set them equal to each other. We're going to solve for x. So if you want to simplify this a little bit before you start, you could divide both sides of the equation by 6. So this would make this 2, and this would make this 5. I realize that if you're using a calculator, it's a waste of time. But again, if you want to work with smaller numbers, it might be something you want to do. So this is 2x is equal to, this will be 5x minus 15. Let's subtract 5x away from each side of the equation. And so this is going to cancel. Looking at this guy, so 2x minus 5x would be negative 3x. And this equals negative 15. Let's divide both sides of the equation by negative 3, like this. And so let's cancel this with this. And so let's say x is equal to negative 15 divided by negative 3. That's going to be positive 5. And so the number of hours the cargo train travels before the passenger train caught up is going to be 5. So let's put this as 5 hours. It's going to be the answer for our problem. And just going back through and checking things, you can think about this. So the cargo train, again, left Los Angeles and traveled toward Las Vegas at an average speed of 12 miles per hour. So we already know that it traveled for 5 hours. So 12 times 5 is 60. So that means for the cargo train, it's going to travel 60 miles, right? From where it started to where they catch up. Then going back through this part, a passenger train left 3 hours later. So basically it's going to travel for 2 hours. And then it says, and traveled in the same direction, but with an average speed of 30 miles per hour. Well, again, 30 miles per hour for 2 hours would be 60 miles. So this passenger train is going to also go for 60 miles. So again, they start at the same point and they end up at the same point when they catch up. They're both traveling 60 miles. So this is our correct solution. The cargo train is going to travel for 5 hours before the passenger train catches up. All right, let's take a look at problem 3. So a cruise ship left Puerto Rico and traveled toward Europe at an average speed of 10 miles per hour. A U.S. Navy submarine left 4 hours later and traveled in the opposite direction with an average speed of 25 miles per hour. Find the number of hours the submarine needs to travel before the two ships are 145 miles apart. So this goes back to our first problem in the practice test, where again, they're traveling in opposite directions, and so you have to sum the distances to get to this total number of miles, which is 145. Okay, so that's the setup here. Let's go down and let's fill this out. So we have D is equal to R times T, or distance is equal to rate of speed times the amount of time traveled. So in this case, we're going to have a cruise ship, so a cruise ship, and then we have a Navy sub. So let's just put a sub like this. We make that U a little bit cleaner. So coming back up here, let's see if we can get some information. So for the rate of speed, it says that the cruise ship traveled at 10 miles per hour. And then for the Navy ship, it's going at 25 miles per hour. So I'm just going to fill that in for the rate in each case. So this would be 10 and this would be 25. In terms of the time, since we want to find the number of hours the submarine needs to travel before the two ships are 145 miles apart, let's let X be equal to that. So let X be equal to the number of hours. I'm just going to put for the sub, just so we can fit that on the screen. So for the sub, you can just pause the video and write out whatever you need, but it's just going to directly answer this question here. So that's going to be X, and it tells us specifically that a U.S. Navy submarine left 4 hours later. Okay, so that means it's going to travel 4 hours less than the cruise ship does, again, when they're 145 miles apart. So the cruise ship would travel 4 hours more than the submarine. So I can take X for the number of hours for the sub, and then X plus 4 for the number of hours for the cruise ship. So I'm going to put X plus 4 for the cruise ship. Again, it travels for 4 hours more than the submarine does, and the submarine will just be for X hours. So multiplying these, again, all I'm going to do here is multiply across. This is 10 times the quantity X plus 4, and this will be 25X. So now in this particular case, you want to sum these distances and set this equal to this 145. Again, that's how far apart they are. So what we'll have is 10 times the quantity X plus 4, then plus 25X is equal to 145. Again, the distance that the cruise ship travels plus the distance that the submarine travels, those amounts are going to sum to a total of 145 or 145 miles. Okay, so you can divide everything by 5, again, if you want to work with simpler numbers. So this is going to be 2 times the quantity X plus 4 plus 5X is equal to, this would be 29. Again, I just divided everything by 5. You don't have to do that if you don't want, it's up to you. So this will be 2X plus 8 plus 5X is equal to 29. So 2X plus 5X is going to be 7X. And then plus 8 is equal to 29. Let's subtract 8 away from each side of the equation. And so this is going to cancel here. Coming back, we'll have 7X is equal to 29 minus 8 is going to be 21. Let's divide both sides of the equation by 7. We're going to get X is equal to 3. All right, so coming back up here, the answer here is going to be 3 or 3 hours. So that's the number of hours the submarine needs to travel before the two ships are 145 miles apart. Again, checking this, we know that for this Navy sub, it's going at 25 miles per hour, and it does this for 3 hours. So for the Navy sub, it's going to travel 75 miles, right? All I did was multiply. 25 times 3 is 75. Then for the cruise ship, it's going 10 miles per hour. And again, it's going to travel for 4 hours more, right? So it's going to do this for 7 hours. So for the cruise ship, it's going to go a total of 10 times 7 or 70 miles. So 70 miles. Again, if you sum these two amounts together, the 75 plus the 70, you get the 145 miles. Once again, if you wanted to do a little visualization, you could just say this is the starting point. And let's say one of them goes left. Let's just say this is the Navy sub. So this is the Navy sub. And so at this point, right here, it's traveled 75 miles. So let's just say this is 75 miles. And then for the other guy, let's just do this in a different color. This is the starting point. And now it's going to go 70 miles. And again, I know this is not the scale, but it's just to get a visualization. So let's say this is 70 miles, and this is for the cruise ship. And then again, if you took the distance between right here and right here, you would just sum the two. The 75 plus the 70, which gives you the 145 miles. Again, so we know our answer here is correct. The submarine, or the Navy submarine to be more specific, travels for 3 hours before the two ships are 145 miles apart. All right, let's take a look at problem number 4. So we have that Ted left home and drove toward his fishing cabin. 2 hours later, Adam left driving 18 miles per hour faster in an effort to catch up to Ted. After 3 hours, Adam finally caught up with Ted. Find Ted's average speed. So again, when you hear the word caught up, you know that you're going to be setting the two distances equal to each other. Okay, so that's important. So coming back, I want to put distance is equal to rate of speed times time. And then in this scenario, we have Ted and we have Adam. So let's put that in there like that. So coming back, if we want to fill out our table, we're asked to find Ted's average speed. So let's just let X be equal to that. So let's let X be equal to Ted's average speed. And of course, this is going to be in miles per hour. And so we can use that in our table. We know that Adam is going to drive 18 miles per hour faster than him. So for Ted, it's X, and for Adam, it's X plus 18. So for Ted, it's X, and for Adam, it's X plus 18, because again, he's going at 18 miles per hour faster than Ted. Okay, in terms of the time, it says after 3 hours, Adam finally caught up with Ted. So Adam is going to travel for 3 hours. And then it says that Adam left 2 hours later, right? So basically, Adam is traveling for 2 fewer hours than Ted does. So Adam is going to travel for 3 hours, and Ted is going to travel for 3 plus 2 or 5 hours. So let's go down here. So for the time for Ted, let's put 5 for 5 hours. And then again, Adam is going to travel for only 3 hours. Okay, for the distance, again, we're just going to multiply across. So 5 times X is 5X. And then you would have 3 times the quantity X plus 18. Again, because it's a caught up scenario, we're just going to set the two distances equal to each other. So I'm going to say that 5X is equal to 3 times the quantity X plus 18. So we'd have 5X is equal to 3X plus 3 times 18 is going to be 54. And so let's subtract 3X away from each side of the equation. Let's make this 3 a little bit more legible here. And so what's going to happen is this would cancel, and you'd have 2X is equal to 54. Let's divide both sides of the equation by 2. And so what we're going to see is that this cancels. You'll get X is equal to 27. So this tells me that Ted's average speed was 27 miles per hour. All right, so to check this, we know that Adam left driving 18 miles per hour faster in an effort to catch up to Ted. So 27 plus 18 is 45, and he does this for, again, 3 hours because it says after 3 hours. So 45 times 3 is 135. So for Adam, he is going to drive 135 miles, right, from the point where he starts to the point where they catch up. Then for Ted, let's think about him. It says Ted left home and drove toward his fishing cabin. 2 hours later, Adam left, right? So that means that, again, Ted travels for 2 more hours because Adam left 2 hours after he did. So since Adam went for 3 hours, we know that Ted went for 5 hours, and he did this at 27 miles per hour. So what is 27 times 5? That's going to be 135 miles as well. So he also travels 135 miles. I'll make this I a little bit better. Let me actually make this a little bit better in each case. So this is MI and this is MI, just so that's clear. So each guy here traveled 135 miles from the starting point, which is the home, to the point where they catch up, wherever that is. So we know this answer is correct. Ted's average speed was 27 miles per hour. Okay, let's look at problem number 5. So we have that an Air Force plane left Paris and flew west. A cargo plane left 2 hours later, flying at 385 miles per hour in an effort to catch up to the Air Force plane. After flying for 9 hours, the cargo plane finally caught up. Find the Air Force plane's average speed. So coming down here, again, we have distance is equal to rate of speed times time traveled. And so here we have a cargo plane. And then we have an Air Force plane. Let me just put Air Force, so A period, F period, something like that. So that's my Air Force plane. So coming back up, just to get the information we need, let's let X be equal to, we're asked to find the Air Force plane's average speed. Let's let X equal that. So I'm just going to put Air Force, A period, F period, and I'm just going to put speed. We know what this means. Again, we know this is miles per hour. So thinking about this, I'm going to put this as the rate of speed for the Air Force plane. And for the cargo plane, it's 385 miles per hour that's given to us. So for the cargo plane, again, this would be 385. For the Air Force plane, it's going to be X. For the time, it says after flying for 9 hours, the cargo plane finally caught up. So I know the cargo plane travels for 9 hours. So I'm going to put a 9 here for the time. So thinking about the time for the Air Force plane now, we see here that a cargo plane left 2 hours later. So that means that the Air Force plane traveled for 2 hours more than the cargo plane did. So coming back, we think about the time for the cargo plane is 9. So the time for the Air Force plane is going to be 9 plus 2 or 11. Again, I can always just multiply across. 9 times 385 is going to be 3,465. and then 11 times x is just 11x. Again, we have a scenario where the distances will be the same. We have this key part right here where it says finally caught up. So again, they start from the same point and then they catch each other. So they go the same distance. So for this problem, we already know we just set the distances equal to each other. So we say 11x is equal to 3,465. And that's a very easy equation to solve. We just divide both sides of the equation by 11. This would cancel. We get x is equal to 3,465 divided by 11 is 315. So coming back, the Air Force plane's average speed in miles per hour would be 315 miles per hour. And again, you can always check this by just reading back through the problem. We know that a cargo plane left 2 hours later, or again, it flew for 2 hours fewer or less than the Air Force plane. And we know the cargo plane, again, when they finally caught up, was flying for 9 hours. So the Air Force plane was flying for 11 hours. 11 times 315 is 3,465 miles. Again, so this is for the Air Force plane right there. This will be equal to, if we look at the cargo plane, again, it's 385 miles per hour and it's 9 hours. So 385 times 9 is again also 3,465 miles. And this is going to be for my cargo plane. So again, these are exactly equal in terms of the distance. So we know our answer is correct here. The average speed for the Air Force plane is going to be 315 miles per hour.